Hi everyone, welcome back to the System Thinking in Engineering Mechanics Statics, and now we in the chapter of three-dimensional vectors. I don't forget to put more practice in here. Last video I talking about the step of additionals of several vectors in terms of three-dimensionals, and we can divide it into three systems that the equation normally give to you. So I just found this question from the R.C. Hibbeler Engineering Mechanics, Static and Dynamics, and I think this is the good trick question that you should practice this. So is this question number 273. The shaft S exert 3 force component on the die D or the point D. Find the magnitude and the coordinate direction angle of the resultant force. Force number 2 or the second force act within the odd tangent. So the question give you 3 force here, 3 forces here, F1, F2 and F3. For F1 it is actually one-dimensional force. F2 you can see from these rectangles. So this one is the two-dimensional force acting on Y and Z axis, and the first one acting on the X axis. And how about the third one, the third force? Yes, it is three-dimensional force, but the question is which system that they give you. Let's pause this video a while we think for the solutions, and then we will come back with the solution. Can you find out how to solve these questions? The question gives you 3 forces and they are for the resultant force. So for the first force, F1 here, it is 400 along the x-axis. So you can write down the vector of force 1, number 1, as 408. And then the force number 2 here is 200 cos theta, which is 4/5 J. And then this one go the opposite way of the y-axis, so it should be minus. And then plus 200 3/5 K. You can use your calculators and find out it is 160 J plus 120 K, like this. How about F number 3? In this question, they give you the 2 angles of this one, but it is quite a trick question. So the angle that they give you is the angles between F and C axis, and for this one is the angle between F and Y axis. F and x-axis. So actually this is the angle of triangle system. So it means that this one should be equal to 300 cos 60 I and then plus 300 cos 60 k. But they didn't give you any angle between force number t and the y-axis. So let's start with find out the numbers here. We can write down F3 as 150 I plus, let's say Fy here J and then plus 150 K. And you know that the F component should be equal to each component plus together. So we can write down it as T square should 300 square should equal to 100 square plus Fy square plus 150 square. And then Fy will be equal to 300 square minus 150 square minus 150 square and square root of this one. So write down the equations and then you find out the answer. So this is square root of 45,000. Or it is 212.1. So that's it. We can have F3 equal to 150 I plus 212.1 J and 150 K. So after this, you may combine every term from F1, F2 and F3. Let me move this a little bit. Like this, and the resultant force will be equal to 550 I. This is plus 52.1 J and then plus 270 K. So you know how to find out the magnitudes and the directions, angle, right? Magnitude will be equal to the square root of this one. And then it should be equal to cos theta, if theta is the angle between x and fr here will be equal to the magnitude of fr by itself like this. So you can find out all of the answers. And this is some trick question for three-dimensional vectors. Thank you guys. See you next video.